In this video, we're going to go over a very brief introduction to two-sample hypothesis testing. So far, we've been looking at examples of one sample hypothesis testing when you're actually looking at population parameter of one population. For example, we wanted to see if the average credit card balance of US citizen is, for example, is equal to 1,000 or not, $1,000 or not. So that is actually looking at one population group and looking at one specific population parameters. Whereas in a lot of practical cases, we are comparing population parameters coming from two or even more than two population groups. Here, we want to focus on two-sample hypothesis testing, which is actually mainly about comparison of two population groups, right? So if we, for example, if we want to compare the average GPA of students at Cal State University versus average GPA of students at University of California, UC system. So now we have two population, two different set of people that each belong to a different university system. So this would involve a two-sample hypothesis testing, right? Comparing the population mean of these two population would involve a two-sample hypothesis testing. We need to take two samples, one from each population. If you are looking at, if you try to compare the retail price of items sold at Walmart versus Target, again, you have two different population, items sold at Walmart versus items sold at Target. So two completely different population. And then again, you need to run a two-sample hypothesis testing. You need to take two samples and compare them. If you have two suppliers and you want to see which one has a shorter lead time. So you have orders, like historical orders coming from supplier one, that would be your population one, historical and future, but your sample is going to be from historical orders. And then, so the one actually dealing with supplier one and another population dealing with supplier two. And then again, you need to take two random samples and then make the comparison. So that is basically how this two-sample hypothesis test works. In general, in the cases that we're going to do in this course, we're going to be looking at population mean, comparing population mean of two populations, and comparing standard deviation of, again, two populations, standard deviation of a specific variable coming from two populations. The way it works, we're going to take random samples, two random samples, one from each population, and then we take sample statistic for each one of them. And then using these sample statistics, we're going to find the test statistics. And coming from the test statistic, using the test statistics, we can go ahead and find the p-value and then make the conclusion, right? The two-sample hypothesis test, similar to one-sample hypothesis test that we have seen so far, can be a two-tailed test, lower tail type of test, or upper tail type of test, right? So the two-tail type of test, we want to see if the difference between population parameters is not is different from a certain number. And then the null hypothesis would be if the difference between them is exactly equal to a certain number. In most cases, when you want to just compare these two values just to see which one is bigger than the other one, you just put 0 and basically you check to see if they're equal or not. If you put, instead of these 0, if you put 0, you are basically testing to see if population parameter 1 is equal to population parameter 2, and if and then the alternative would be if they're not equal or if they're different, right? So I said the two-sample hypothesis test can be two-tailed or lower-tailed if the difference between the first and second population is strictly less than a certain hypothesized value, hypothesized difference. If that is our research question, this is called a lower tailed type of test. And if the difference between them, difference between the population parameter 1, the first one, and the second one, if that is strictly greater than a certain hypothesized value, that would be a case of upper tailed test. All right. So and then again, similar to one sample hypothesis test, after you develop the null and alternative hypothesis, and after you decide about the level of significance, the third step, finding the test statistic. This is, as I said before, the test statistic is different from any type of hypothesis testing. So from a hypothesis test to another type of hypothesis test, the test statistic is different. So if you're doing a population mean, a test for population mean, the test statistic is different when you're doing a test for population proportion, and so on. When you are doing a two-sample hypothesis test, the test statistics are getting more and more complicated. And because of that, we're not gonna even see the formulas. We're gonna just use Excel in this course to conduct two-sample hypothesis tests, right? And then the list of tests that we're gonna go over, here you can see the list. So we have, we're gonna do two-sample tests for population mean. We have actually 4 of them. Among the first 3, I'm going to explain later on. We're going to use the second one, which is the most general case, two-sample, assuming unequal variances. So this is among the first 3, which all are for T-sample tests for means when you have independent samples. The second one, actually, when you have unequal variances, that would be a more general case and includes the other 2. So this is one of them. And we also do a paired two-sample test for means when you have dependent or paired samples. Basically, well, I'm gonna explain later on, but here we have the same items belonging in both samples. So if you are comparing, for example, retail price of Walmart versus Target, if you're picking exactly the same items and comparing their prices one by one, this would be a case of paired. But if you take random list of items from Walmart and random list of items from Target, and then to compare the prices, that would be a case of independent samples, and that would be this type of test. I'm gonna explain the difference later on. So 1, 2, and then 3, two-sample test for equality of variances. So we're gonna do these 3 type of tests for two-sample hypothesis testing.